So we're back to our process. Now this was a simplified statement of how the process is going to go, but you can see that the simple ladder program didn't work. So let's take a look at what we need to change. So the first thing we're going to do is define two states. One is the forward state and the second one is the reverse state. And so what we're going to do in the program is when we press the start push button, what we're going to do is we're going to latch a bit. We're going to call the bit forward, and we're going to latch it true using the latch output. Then we're going to extend A. Now we're going to use that forward bit to signal to the PLC program that we're in the forward state. So none of the reverse stuff is going to have any effect. So we're going to see that if forward is true and sensor A1 goes true, then we're going to extend B. Then if forward is true and sensor B1 goes true, then we're going to extend C. So once we get C extended, we're now at the end of the forward phase, and we're now going to go into the reverse phase. So the sensor C1, as soon as that gets triggered by the cylinder, we're going to have the C solenoid or C cylinder retract, but we're also going to unlatch forward. So forward is going to be set back to false, and we're going to latch another bit called reverse. Now we're going to use the state of the reverse bit as a condition to tell the cylinders to go in reverse. So if reverse is true and we see sensor C0 go true, we're going to retract B. If reverse is true and sensor B0 goes true after B has retracted, then we're going to retract A. And then the last thing is when sensor A gets triggered, we're going to just revert. We're just going to unlatch reverse and set it back to false. All right, so let's go back to the program and see how that's going to work. So we need to insert some rungs. So now inserting rungs in Automation Studio, you actually have to go to the ladder menu up here and click Insert Rung. And then it kind of shades out. You put the shaded area where you want the rung to be inserted. So we're actually not going to be so much inserting a rung as adding to the top rung, but we have to make some space for it. So if I click here, it makes some space. And so I'm going to be going back and forth between the PowerPoint and this to just make sure we're taking the right steps. So what we want to do in this first rung, when we start the push button, is we're going to latch, we're going to extend A. It already has that on the rung. We're going to add this latching output to latch this forward bit true. So we need to go over here to ladder for Allen Bradley PLC, ladder for Allen Bradley PLC 500 PLC, and in the submenu, it doesn't show up. The latched output doesn't show up in the top menu, so we have to drill down a little bit. We have to go to this bit menu, which gives us more options of types of outputs. So this OTL is the output latch, and we're just going to place that up here below the A+. So we need to give this an address, and it's going to be an address for an internal bit. Now this Automation Studio has a little help menu here. If you click it, it shows all the formats of the different types of addresses that you can use and all the ranges that you can use. So the internal bits have to start with B3. It's a file 3. So the format has to be B3 colon and then something slash something. It starts at 0/0 and you can go all the way up to 255/15. So I'm going to just go ahead and use the first available address there. So I'm just going to type it in, B3 colon 0/0, and we're going to give it an alias. That's the name we're going to use for it, and that's FWD. I'm just abbreviating forward. Oh, I gotta save changes. Okay. So now that's been labeled the forward bit. I guess it's still on insert run. I just had to hit escape to get rid of that. So we're just going to connect this up here like this and connect this so those are now in parallel. So what I'm going to do is add this forward bit as a condition on the next two rungs. And so I'm going to make some room for, I'm going to slide this condition over a bit and this one as well. And just add another input. I think if I just pop it on the rung, I don't have to delete the rung. I think it just pop it on there. So now that I've created this forward bit, I don't have to I could type the address in or the alias, or I could just pick it off the list. See, it now shows up down here among my available addresses. So I'm just double click that, and I'll put another one right here. And just to show you another way to do this, if I type in FWD, it already knows, it recognizes that, and it puts the address in. So you can also do that. Oh, save changes, yes. Okay, so now the two conditions for extending B are that the forward bit is true and the A has extended. And once B has extended, as long as the forward bit is true, C is going to extend. Okay, now let's just pop back over here. So now that C is extended, the sensor C1 is going to go true when it's fully extended. That's the point when we want to first retract C, and then we're going to unlatch the forward bit and latch the reverse bit. And then we'll use the reverse bit to indicate the reverse state. So here's where C1 goes true right here, and I already have the input that's going to retract C. What I have to do though is insert another space. It's not really a rung, but it's a space. I need two of them. And so escape to get out of that. So now I'm going to unlatch the forward bit. So let me just, again, I can grab this off the list down here. And I need to latch the reverse bit. So I haven't created the reverse bit yet, so once I put this down, now I'm going to use another bit address, B3:0/1. I'm just going to grab the next available address, and we're going to call that REV for reverse. And now we just have to connect these. Okay, let's pop over here again to our slide. So now we get it on the next two slides. When C retracts and C0 goes true, if reverse is true and that happens, we're going to retract B. So all we have to do here is add the reverse condition to that rung that's going to retract B, and the reverse condition to the rung that retracts A. So let's go ahead and do that. So again, I'm going to slide this over here and this one over here, and just add those reverse bits. So I'm just going to go ahead and type it, and when I hit enter, it comes up with the correct address. And then one more over here. Might as well grab it off the list. There it is. Okay, looks like I got this wrong here. This should be A- at the end. I don't know, that must have been a mistake from before. So I'm just simply going to double click that, and here's A-. Okay, So that's going to retract A. And then the last thing that happens is when it finally gets all the way done and A is finally fully retracted, we're just going to unlatch the reverse bit. So I just need one rung at the end. All right, so after making all those changes, we're going to see if it works. And so we click on normal simulation, and it looks like we have an error. And I actually did this deliberately because I want you to see the error. This is one of these little Automation Studio things that's a little picky. So if I click OK, it sort of disappears. But if you look up in the right-hand corner, there's a red flag that's flashing. So it says new messages. So that's where I can get the error messages. And what I'm seeing here is there's a few errors from the latest attempt at running it. And if I click on it, it actually highlights the error. So now this is something that Automation Studio's ladder diagram editor is very picky about. It doesn't let you connect this directly to the other power rail. I have to make this connection up to this point when I have outputs that are in parallel like this. So I'm gonna go ahead and correct that. Just click on it, delete that little segment, and then reconnect it up here. So if you happen to be fooling around with your ladder diagram and you make that connection, I know that if you're working with RS Logix 500, it draws that way, but it's just one of those little Automation Studio things, and I'm not sure why they made it so picky. I can click on the other errors, but they're the same issue. Anytime you have this parallel, you actually have to run it up here, so there's only two connections on either end of the power to the power rails. I call this power rails. That's what they're called. They're virtual power rails. It's kind of like reflecting a hardwired logic diagram. But all right, so let's just make that correction, and we're done with this. And I think that will do the trick. Try it again, normal simulation, and looks like things are running. There's no errors. Now there's a warning message that shows up, but that doesn't affect the function. It's just saying some component doesn't have a connected pin. So we know that there's a few pins that we haven't connected. All right, so let's try running our program. So if I go over here and click the start button, A extends, B extends, C extends, C retracts, B retracts, A retracts. Excellent. Okay, looks like everything is working properly. So I'm going to stop the simulation. And before I do anything, I want to save this. Now we're going to create another application. We're going to make some modifications, and I want to have some names that distinguish between the two. So I'm going to save this as, I'm going to create a new name for it called Sequential Process 1. And I'm going to call this ABC Actuators.